Welcome to Southwest Wyoming and another episode of Random Road Cuts. Thanks for joining me. I'm Geology Professor Shawn Willsey. First of all, just really appreciate all the great response I got from the first Random Road Cut. I had no idea. It was sort of a shot in the dark. I thought it might be a flop, to be honest, but it really seemed to be fun and resonated with a lot of people. In all transparency, the second episode was shot first, but that's when the idea was like even further in the back of my brain. I was going climbing and I thought, well, I could just do a little quick video of a road cut. And then by the time I got to the first one you saw in Nevada, the idea kind of, organically grew a little bit, and I had a little better idea of what I wanted to do. So that's why that one became the first one. But this is episode 3. I was just at Fossil Butte National Monument, and I'm a little bit north of Kemmerer, Wyoming. This is US Highway 189. And I thought after I got gas in Kemmerer, I thought, well, shoot, I'll just find a random road cut and call it good. So let's start with what we know about this region, maybe what I know a little bit, and you may know as well. This is somewhat broad knowledge in terms of regional geology here. So southwestern Wyoming is what's known as the fold and thrust belts. We have a series of anywhere from Mesozoic to some Cenozoic rocks that have been shoved eastward, mostly Mesozoic, I guess, rocks that have been shoved to the east. Sometimes they're faulted and folded, and mostly sedimentary rocks here. So as I kind of look at this outcrop, knowing I'm in this part of Wyoming, knowing I just left the Fossil Butte National Monument where there's shales and fossils of fish and other organisms, the sedimentary rocks would seem to be the main theme that we have here. What else do we know about this area? Well, we're in Wyoming, so we know that there's quite a few natural resources that are exploited out of the ground, oil, gas, coal. So that's something to keep in mind. Otherwise, as I'm looking at this outcrop with these beige and grayish rocks, I'm thinking probably a sandstone, maybe a limestone. In between those little cliff faces there could be some shale. Who knows, right? But let's tackle this like we did before, and maybe we'll start here on the north side of the outcrop and work our way across, but also kind of climb and work up section from these presumably older rocks up through the younger rocks there. And we can see the rocks are just very gently dipping to the south or to the right here. So let's just start at the bottom. And it looks like beneath these brown sandstones, the soil's kind of black. I don't know if there was a fire there or if that's actually rocks. Oh, that's actually rocks, I think. Let's climb up a little bit and see. Oh, someone's dug a little hole in it. Okay, so let's start with the brown rocks. We've got brown bedded sedimentary rocks here. Touching them, they feel gritty to the touch, a little bit sugary looking. This is a classic sandstone, a nice fine to medium grain sandstone. A little bit of iron oxide on some of the faces there. What's interesting about this sandstone, it could be a fossil right there. Oh, okay, so let me show you a couple other things I'm seeing here. A little bit more over here, and coming up here, we have a whole series of this material in this. Again, it's my first time here digesting it with the rest of you. A couple other things. Oh man, I just keep hitting them out of the park with these random road cuts. What do you see here? So our main bedding surfaces are here and here. But in between, I hope you can make this out, in this gray unit between my fingers, there's some cross bedding. So there's some layering coming across at an angle, but it's fairly low angle, which suggests it was probably running water, streams, rivers that produce cross bedding like that. What else do we see in here? Let's get back to those shells. I think this thing has some fossils in it. Let's come back to these. Okay, I'm no paleontologist, but these look like either clams or oysters in this kind of fine to medium grain sandstone. Let's see if we find some other ones. And then we need to come back to the black stuff that's underneath my feet. So, looking. So if these were, let's say, clams or oysters, there's another one right here, then that would help us interpret the environment. Oh boy, here's some more up here, in which these rocks were deposited. All right, so here's, I think this is pretty much a slam dunk, at least as far as I'm concerned. These are definitely, I think these are oysters here. And so that makes our sandstone then not a sand dune deposit that was windblown sand. It makes our sandstone here more likely to be a marine deposit, a beach sandstone, I'm thinking. Although I don't know a lot about oysters, and maybe, are there freshwater oysters? I don't know. Again, the purpose of this is more making observations and just kind of leaving everything open and on the table. But let's get back to, at the bottom here, there's this black material right at the base of the sandstone. There's a really abrupt transition here, assuming this block of sandstone's in place. And then we get this black material. It's brittle. I can break it with my fingers, my hands. This is coal. This is bituminous coal. Again, which is common in parts of Wyoming. All the coal in Wyoming is Cretaceous in age. So again, just knowing a little bit about the area, I'm pretty confident that I'm looking at Cretaceous aged rocks in this part of Wyoming, because I know that the coal in Wyoming is Cretaceous in age, also the same as the coal in Utah. So coal is formed in a swamp. So coal is actually the undecayed remains of plants that were living in a swamp, died, sank to the bottom, got compacted, but because of the lack of oxygen and circulation in the swamp, that material turns into coal. And then of course it can be burned to generate electricity, hence coal burning power plants and some of the coal mines we have in the area. So what we have then, I know I'm slipping into interpretation mode, but I think I'm a little bit excited. The coal represents a swamp. Then we have a quick transition into our sandstones, our oyster bearing sandstones. In fact, as you look at the edge of it, I think a lot of these little things are actually the oyster shells. So I think these may be the oyster shells in profile view, in cross-section view. We'll have to see if that's true, but that would be another. Actually, I can kind of see a little bit of a shell right there. Let's see what else. Yeah, there's definitely some shells in there. So then we would have a transition from swamps to this coastal sandstone, but still underwater, so a very shallow marine type of sandstone, which would necessitate a sea level rise, because swamps where the coal formed would not form in the ocean. They would need to be on land, but it would be a near shore, near coastal swamp, maybe like what you see in Florida. Here's some more oysters. You can see the kind of pearly luster on some of these shells here. So it blocks us the sandstone that have a lot of this fossil material in it. Okay, so let's work our way up the section. So we've got the coal in the road cut down by my truck, transitioning into this tan, kind of fine to medium grain, somewhat cross-bedded, oyster-rich sandstone. This is great. What a fun little spot right here in Wyoming. And it's fun to think, to me it's really fun to think about, here I am at like 7,000 feet in the sagebrush plains of Wyoming, and yet we're looking at rocks that formed in a swamp, in a tropical, wet, temperate type of environment. Pretty remarkable. Of course, the other thing that was going on in the Cretaceous that you may be aware of is that we had a big interior seaway. So from the Wasatch of Utah eastward, remember the Rockies did not exist in the Cretaceous, so the entire middle section of the country was covered in a big arm of the ocean that spread, here's some more oysters here, that spread down from Canada and up from the Gulf of Mexico, and it effectively split North America in two. There might be some wood in here too, like twigs, or maybe those, I think those, I don't know. There's some other material in here besides the oyster shells. There's a nice piece of it there. So these rocks, again, you know, not knowing anything specifically about these rocks, very likely Cretaceous based on the age of the coal that we found. And now we're seeing marine organisms, oysters, which also jives well with parts of the Cretaceous, because we had the Cretaceous interior seaway. So again, this is where, you know, you don't have to know everything about the geology of your area, but just knowing a couple things, just those few little clues, can sometimes make a big difference. So then we have a slope that's covered, a little hard to see what's going on here, and then we get to another cliff forming unit up here in the shadows. The rock color changes a little bit to more of a light gray, maybe kind of a mauve. Let's see what we think this stuff is. Again, feels pretty gritty. There's some nice layering in this. So this looks like a fine-grained sandstone with some iron oxide staining on some of the fracture surfaces. That's where we get the reddish color there. Let's trace this one down, and then we can move back up, just so we're not doing anything too crazy and sporty. So essentially, so far, we've seen at least 3 different units in the Roadcut. The coal at the bottom, the sandstone with the oysters, a second sandstone here, and I'm not seeing any oyster shells or any fossils in this so far. So this sandstone looks less fossiliferous than the first one we looked at. And again, we're not going to know the name of this unit right now. We could probably figure it out later by looking at a geologic map. We're just doing some good old-fashioned detective work. And actually right now we're doing a little bit of scrambling. The thing about road cuts is they tend to be steep. So, okay, so there's the sandstone layer below us. There's another slope right here we're standing on, and then another outcrop there. But in between all these particles, I'm seeing more of the black. So I'm wondering if there's more coal, another bed of coal that's forming this slope between these sandstone beds. And I'd bet my lunch, yeah, here's some good pieces here. Let's dig right here for a second. Yeah. Okay. So now we're seeing another coal bed here. Black, brittle. It's a little bit different quality of coal than the first one we saw. Again, I'm not an expert on coal, all the lignites and that. I would still probably call this bituminous coal, just based on its characteristics. We've got another layer of coal in this slope, and then we've got a nice sharp contact with some more sandstones, and then we're almost to the top of the road cut here. Let's see what else. There's this Interesting little gray layer. And if we kind of get back up in here, hope you guys can see that. There's another layer sitting on top of where we're really digging now. So it looks like we've got the coal here, and then there's this maybe like a 5-inch layer of maybe like a mudstone, yeah, or different kind of sandstone. But you can see it's it has different layering characteristics. It's forming sort of little pinches and swales, a little different than what we see in the sandstone itself. So a little different layer there, and that's what I think's weathering out onto the surface here to make these purplish chips. They feel like sandstone. I have not tested anything so far, and I apologize, I just remember I had this with me with the handy dandy acid bottle. They're not really fizzing though, so these are not calcite rich. Even the sandstone, the little block that weathered down, isn't either. That could be an erosional surface, or it could just be a different rock type in there. But nevertheless, then we end up with a beige sandstone here, forming this bench that comes across the road cut. And this is a little bit different bedding. We can see it's a little thinner. It's almost flaggy, right? It breaks into, it's thinner bedded. It's breaking into beds that are maybe just a few inches or a few centimeters in thickness. This, what is this stuff? This may be wood. So I wonder if this is a little bit of wood in this sandstone. It's again sort of fine to medium grained. It's so interesting, these three sandstones have been somewhat different. And a lot of this stuff's moved out of place. Let's go up to this outcrop here. Oh, stay with me. Okay. Brown sandstone. Am I seeing anything? Ooh, what's this? I guess what I think I'm seeing, and I'm just talking out loud now, I think there might be more of these oysters in here. So let's kind of hunt around a bit. There's definitely some fossil material in here. I'm just not ready yet to say definitively what that material is. So, as always, the best thing to do is to keep looking, right? The worst thing you can do is just like pick up one rock, cast judgment or an interpretation upon the whole thing, and then find out later that you screwed it up or you didn't look around enough. So let's see, there's some white caliche coating some of these. That's just an erosional characteristic. Let me just make sure. Everyone loves the acid test. There you go. So there's some caliche fizzing with the acid, and then sure enough, yeah, these look like oysters to me. Some of the little, just the texture is very, looks a lot like what we saw down lower. There's one that's actually weathered out a little bit. You can see how shiny that is in the light. So I think we have another oyster bearing. I'm not going to call it oyster rich because they appears to have less of the shells than the lower sandstone. But either way, yep, there's one right there. Let me set that up for you. It's a nice white one right here. Nice shell there. So we've got this other sandstone with some shells in it, fossil material. Another one down there. Yeah, so I feel really good about this interpretation now. Oh boy, here's a whole slab of them. So just broken. So we can see, and a lot of the shells are not intact, right? I probably have yet to show you a complete intact oyster, which tells us a little bit that this was an environment in which there was some energy, right? So these oysters were living and dying, but then they were getting moved a little bit. Probably the wave action along the coastline was busting up these shells to some degree before they got buried and deposited. Here we can see a bunch of impressions of like where the shells, that's what I think these are anyway, of the oyster shells sitting in the sandstone. Pretty cool. So let's head back down and maybe summarize it all. Oh, and that second black coal that's right underneath us looks like it is exposed in the road cut much more distinctly down here. So let's see if we can make our way down through the sandstone with the oyster blocks and take a look at that. Yeah, I'm seeing more of these oyster shells scattered throughout. All right, one more big move here, and then I think we're there. Yep. Yeah, so notice here, oh great, here's a nice outcrop of it. So down here, it's actually fully exposed as an intact layer of coal. So there's that nice brittle, that's just beautiful, classic bituminous coal. Black, glassy, brittle. You can break it with your hands. Because remember, it's just all it's made out of is compressed plants from a swamp. And so this is one of the major commodities in Wyoming, is this coal that gets mined to produce power and energy. So, okay, let's scramble down and take one last look. So you can see the sandstone just above it, then the bituminous coal. And then as we work our way down, here was that gray, that second sandstone that appeared to not have a lot of the oysters. Although, you know, if I spent some time here and looked, maybe we would find some. So, yeah, so we worked our way more or less to the south end of the outcrop. We had coal at the bottom near my truck. Then the brown sandstone where we first saw, with the crossbeds as well, where we first saw some of the oyster shells. This slope was largely covered, but it looks like over here, it also maybe has, so I can trace it from there over to here, and it might have a little bit of that coal in it as well. We need to dig that out. But then this middle sandstone, then the coal layer, and then the upper sandstone that also has a few of the oyster shells. And so what I think this whole outcrop is telling us, so fundamentally 5 layers: coal, sandstone, maybe a little bit of coal, sandstone, coal, sandstone. It's really not varying beyond those 2 rock types, at least broadly. And we're seeing evidence then, I think, of sea level fluctuations. So when the sea is low and this place is a freshwater swamp near the coastline, we get coal. When sea level rises, we get these sands, these kind of coastal nearshore beach sands with the oyster shells being deposited. And then sea level drops and we're back to another swamp with the coal forming, and then sea level rises, so on and so forth. So the Cretaceous interior seaway was connected to the ocean and experienced the same fluctuations in sea level that you would experience at any coastal location. So pretty awesome. I was really happy with this random road cut. I hope you were too. Little bit of stratigraphy, looking at the layers, a little bit of sleuthing with the different sedimentary layers and sedimentology. We got some fossils in there. We got a bed of economic geology with the coal. Pretty nice. So thanks for joining me again at this random road cut on Highway 189, just a bit north of Kemmerer, Wyoming, in southwest Wyoming. Thank you for supporting the channel with all you do, with donations, with sharing, liking, subscribing. All that stuff makes a big difference. helps me just sort of spread the geology to other folks, which is my passion, is just getting more people involved with geology, more people just opening their eyes to the natural landscape and the wonders that surround them. So thanks again for joining me, and we'll see you at the next one. But this was Random Road Cut number 3.